Hi students, I am B. Srinivasa Rao. Actually, I have started this channel to teach you mathematics covering all the syllabi for intermediate and further competitive examinations such as MSET and JEE mains. Student, in my opinion, if the student practices the problems in mathematics without the proper knowledge of basics and concepts well in the subject, he can't get succeeded. That's why, first of all, he must be very perfect at conceptual things of the subject very well. Then he can solve any type of problems in mathematics well. Keeping that point in my mind, I am going to teach you mathematics from the basic level of the subject in detail, and also I will explain the maximum number of problems in mathematics. So children, I hope that this program will help you a lot. When we want to gain a knowledge in any subject or in any field, first of all, we must have the complete idea about the terms which are related to that subject or that field. Then we can easily understand the content in that subject or field. In mathematics also, there are some technical words which can help us in understanding the mathematical situations well, and then by that we can easily solve the problems in mathematics. So children, let us discuss some important words, phrases, sentences, after that statements which help us in mathematics. To explain the problem or to understand the problem, language is very important to us. There are mainly four types of sentences. They are declarative, imperative, interrogative and explanatory sentences. First of all, let us define an imperative sentence. A sentence which gives a command or a request. For example, complete your homework today, or please give me your book. These are the examples of an imperative sentence. Second one, interrogative sentence. A sentence which asks direct questions. For example, have you finished your homework? Or who is your maths teacher? These are the examples of interrogative sentences. Next one, explanatory sentences. A sentence which gives the strong feeling. For example, what a difficult problem it is and what a beautiful house it is. These are the examples of explanatory sentences. And the next one, that is fourth one, declarative sentence. A sentence which conveys an information or offers an explanation. For example, I am going to my school now, or mathematics is an interesting subject. These are the examples of a declarative sentence. Now, from this declarative sentence, we can define the very important term, that is the statement. Now, let us take two declarative sentences. The first one is, Lord Sri Rama is the son of King Dasharatha, and the second one is, Mahatma Gandhi hails from AP. Now, I am asking you whether the first sentence is true or false. That is, Lord Sri Rama is the son of King Dasharatha is true or false. We all know that he is the son of King Dasharatha. That's why the first sentence is true sentence. Whereas second sentence, that is Mahatma Gandhi hails from AP, it is false statement, false sentence, because he belongs to the state Gujarat. That's why he does not belong to AP. So the second sentence is false sentence. Like that, if you can judge whether the given sentence is true or false, but not both, then that sentence is called a statement. So finally we can say that a statement can be defined as a sentence that can be judged whether it is true or false, but not both. Now let us take the statement 2 is the least prime number. Now tell me whether this statement is true or false. Definitely it is a true statement because of all the prime numbers 2 is the least prime number. That's why this is a true statement. Next, let us take another statement. The sum of 3 angles in a triangle is 360 degrees. Tell me, it is a true or false? It is false statement because sum of 3 angles in a triangle is 180. That's why the second statement is false statement. The truthfulness of the first statement or falsity of the second statement are the truth values of those statements. Now children, we can define the truth value of a statement as the truthfulness or falsity of the statements. Generally, the statements are denoted by small letters such as P, Q, R and so on. Their truth values are denoted by either capital T or capital F. Now, let us define an open sentence. A sentence which cannot be judged whether it is true or false is defined as an open sentence. Let us see this example. He is a good boy. Here, can you judge whether it is true or not? Because we don't know who the person he is. So here we can't judge whether this sentence is true or false. This is an example of an open sentence. Now let us see another sentence, that is x plus 4 is equal to 10. Can you tell whether it is true or not, true or false? We can't, because as we don't know the value of x, we can't judge whether this sentence is true or false. This is also another example of an open sentence. Now children, let us learn about some words or phrases such as or, and, if then, if and only if. These words or phrases connect 2 or more simple statements. Like that, the words or phrases that connect 2 or more simple statements are defined as connectives. Along with these connectives, we will treat the word not also as a connective, though it does not connect 2 or more simple statements. But the word not modifies the given statement. That's why the word not is also considered as a connective. After the word connective, let us define compound statement. For that, I am taking the statements 6 is an even number, 3 is a prime number. Now, let us combine these two simple statements with the connective and. Now, we have got 6 is an even number and 3 is a prime number. Now, the combination of these two simple statements connected with the connective and is defined as a compound statement. So, we can define the compound statement as the combination of 2 or more simple statements combined with the connectives is called a compound statement. Now, let us discuss the different types of compound statements. There are mainly 4 types of compound statements. They are disjunction, conjunction, conditional, also called implication, and biconditional, also called by implication. First of all, let us define the compound statement disjunction. A compound statement that uses the connective or is defined as a disjunction. For example, 2 is a prime number or 2 is an even number. Now let us see, these two simple statements are combined with the connective or. This compound statement is taken as an example of disjunction. In this disjunction, if the first statement is denoted by P, the second statement is denoted by Q, the disjunction of the statements P and Q is denoted by P or Q, like this. Students, now let us discuss how to decide the truth value of the disjunction by taking some example. In a classroom, teacher has given some work to his children like this. Students, you must complete mathematics work or English work. In this situation, if the students complete the work, its a related statement is taken as a true statement. If the student does not complete the work, its related statement is taken as false statement. Now, let us discuss the different cases in this situation. In the first case, student has finished maths work, English work also. So, P is true and Q is true. That's why, in this case, teacher says you are a good student. It means what student has done is right. That's why the truth value of the disjunction is true. That's why true or true is true. Second case, student has finished maths work, has not finished English work. That's why here you will get true or false. In this case also, teacher says yes, good student, because he has given a choice. Either maths work or English work must be done. That's why here teacher says okay, yes, good student, because what student has done in the second case is also true. That's why the truth value of the disjunction is true. Now let us see the third case. In this case, student has not finished maths work but finished English work. Here also he has done one of the works. That's why student has done is what student has done is right. That's why P or Q is also true. And in the final case, that is fourth case, students did not complete maths work, did not complete English work. In this case, teacher says no, because what student has done is wrong. That's why the truth value of the disjunction in this case is false. That's why F or F is false. So this is about the truth value of the disjunction in different cases. The table shows these different cases is called truth table. Now let us discuss another compound statement, that is conjunction. Conjunction is a compound statement that uses the connective and. For example, 2 is an even number and 2 is a prime number. Here let us see, these two simple statements are connected with the word and. So this compound statement is taken as an example of conjunction. If you take the statements P and Q, the conjunction of the statements P and Q is denoted by P and Q like this. Now let us discuss the truth value of the conjunction in different cases. First let us take the example as before. In this case, teacher has given the work to his children like this. Students, you must complete mathematics work and English work. Now let us take the first case. Student has done mathematics work and also English work. Now in this case, what student has done is right. So teacher says good student. That's why first case is true and true is true. So the truth value of the conjunction in this case is true. Now let us take the second case. In this case, student has done maths work and he did not complete English work. So teacher says not good, because he has very clearly given the work that students, you have to complete maths work and English work. Both the works student have to complete. But student has done only one work. That's why what student has done in the second case is wrong. That's why the truth value of the conjunction in this case is false. True and false is false. Third case. Student has not finished maths work and finished English work. In this case also, he did not complete both the works. That's why what student has done is wrong. That's why truth value of conjunction in the third case is wrong. So false. True, false, or false and true is also false. And fourth case, he has not done both the works. So definitely, in this case also, what he has done is wrong. That's why false and false is again false. So this is the truth value of the conjunction in different cases. This is the truth table of the conjunction. Now let us discuss the next compound statement, conditional. It is also called implication. A compound statement that uses the connective if then is defined as a conditional or implication. The conditional of two statements P and Q is denoted by P implies Q like this. Now let us take one compound statement, that is, if a triangle is equilateral, then it is isosceles. You see, this compound statement uses the connective if then. So it is an example of a conditional. Now in this conditional, the statement in the if clause, that is, a triangle is equilateral, is called hypothesis, and the statement after then, that is, it is an isosceles, is called conclusion. So first statement is called hypothesis and the second statement is called conclusion. Now let us try to define the truth table of the conditional. Let us take one example. One person promises his friends, if I get first class, I will give you party. Now based on this conditional statement, let us define the truth table. Let us take the first case, that is, true implies true, which means he has got first class. So true. He has given the party. Second statement is also true. Now let us see what T implies T. He has got the first class and he has given the party. It means what he has promised, he has done. So he is absolutely right. That's why true implies true is true. Let us see the second case, that is, true implies false, which means he has got first class, true, but he has not given party, false. In the second case, everyone says that he is wrong because he has not kept his words up. That's why T implies false is false. Third case, false implies true, which means he has not got first class, false, but he has given party, true. In this case, no one can say that he is wrong. Remember, his friends would say wrong if he says like this, only if I get first class, I will give you a party. In this case, though he has not got first class, if he gives party, he would be wrong. But he didn't say like that. If I get first class, I will give you party. Of course, in this case, though he has not got first class, he has given party. That's why, in this case also, what he has done is true. That's why false implies true is also true. Let us take the fourth case. False implies false. According to his statement, he has not got first class, false. He has not given party, false. So what he has done is absolutely true. That's why false implies false is also true statement. So this is the truth table of the conditional. The next compound statement is biconditional. It is also called by implication. A compound statement which uses the connective if and only if is called a biconditional or by implication. If you take the compound statement, a number is divisible by 2 and 3 if and only if it is divisible by 6. In this compound statement, these two simple statements are connected with if and only if. That's why this compound statement is taken as an example of biconditional. The biconditional of the statements P and Q is denoted by P by M plus Q. And also we observe that P by M plus Q is nothing but P implies Q and Q implies P. Based on this fact, we can easily define the truth value of biconditional. Let us take the first case, that is true by implies true. So B by implies Q means P implies Q and Q implies P. Let us apply the truth values for P and Q. So P implies Q, that is true implies true, means true, and Q implies P, also T implies T, that is T. Again finally T and T is again T. So in the first case T by implies T is T. In the same way we can find the truth values of P by implies Q in the remaining three cases. That is true by implies false is false. Third case, false by implies true is false. And again in the fourth case, false by implies false is true. This is about the truth table of biconditional. Now let us see one more definition, that is negation of a statement. The denial of a statement is defined as the negation of the statement, which means by adding the connective not in the given statement, we can write its negation. If the given statement is denoted by P, its negation is denoted by negation P. Now let us take one statement. The degree of a quadratic polynomial is 2. Let us denote this statement by P. Now let us write its negation, that is negation P is the degree of a quadratic polynomial is not 2. The truth value of the given statement P is true and the truth value of its negation is false. Let us take another example. The sum of three angles in a triangle is 360 degrees. It's a given statement which is clearly false. Let us write its negation. The sum of three angles in a triangle is not 360, which is true. Which means we can understand from these two examples that if the given statement is a true statement, its negation is false. If the given statement is a false statement, its negation is true. The table which shows this information is called truth table of the negation of the statement.